that was an interesting day, full of talks. From what I've seen floating around, we had a great diversity, engagement, and it seems like we hit some interesting context here. So really appreciate all the speakers and all the attendees and all the sponsors, of course. I should mention that Basis Technology and Lexalytics are our sponsors, as well as Nitro, who is hosting this. They're great partners. They're in the gallery, and a lot of you had time to engage with them. They do some really interesting stuff. And David presented, Seth has a talk, and Oleg will be on the panel tomorrow. So we have two panels. Today we have a science panel, so we have questions of what kind of algorithms, what kind of findings we have in NLP, how ready is this for production, and what are the problems people perceive and in the field. Tomorrow we have a panel roughly called Business of Text. The question is, since this is an applied conference, what are the aspects of selling applications using NLP? How do we approach this market? And I think these topics are related, and one cannot be done without the other. So topic today is really kind of scientific experiences. And the plan is as follows. We'll do the introductions, which will take a few minutes, I would say, 3 to 5 minutes each. And when you guys are introducing yourselves, explain the most interesting problems briefly and challenges that you see for NLP to really work, right? As scientists, what do you need to do to make it work? And then essentially, I'll follow up on this and we'll have a conversation. And I think kind of 2/3 into our hour, we'll open up for questions to the panel, which you can direct either at the whole panel, then somebody will answer, or at individual panelists.
Pedro Alves. I'm the chief data scientist at Banjo. Prior to this, I'm fortunate to work with data science and proteomics, genomics, healthcare, disease progression, sports strategies, amongst a few other things, signal processing, social discovery, and now I'm working on event detections. Banjo, what we do is basically let you look at the world through everybody's eyes. So we could look right now at this conference and see in real time what everyone here is posting about this conference, independent of what hashtags they use and independent of where they post it, whether it be Twitter or Weibo or Vkontakte or Instagram. So obviously the main product of this is what we call a crystal ball, which lets you look at the world and understand what's happening, where, why, how, in an instant. The main driver behind that is event detection, which then pulls into text mining, obviously, natural language processing, and image classification. The biggest challenges are understanding context. So we detect events based on the first post. If you wait for a signal with volume, you're too late. So the single first post you have to understand. We detected an Amazon fire, Amazon data center fire the other day, a couple months ago. The post said, "Crazy day at work." I'm sure it was a crazy day at work, but obviously it doesn't have the word fire in it. Or concert from the band Arcade Fire, it's not an arcade on fire. So understanding that context, both from text and from vision. One small example from vision is we detect floods, yet we don't alert Venice every single minute that there's a flood. But when you don't just train on the data and say this is an image of a flood, but when you train with context and you have a deep learning system that understands context, 2 months ago there was a flood in Venice, and our image classification system was able to detect a flood in Venice, which obviously looks very different from a flood anywhere else in the world. So I think that still poses quite a few challenges, and my passion is not necessarily doing something that would be super enticing academically, but enticing to a business perspective, right? A lot of times it's a low-hanging fruit that you can find a solution somewhere that gets you that product that nobody has, and it's not the same path an academic might take.
Thank you.
Hi, my name's Jeremy Howard. I recently founded a new company called Enlitic. Enlitic is trying to change how medicine is practiced. We think of medicine as answering two very simple questions. One is, what's wrong with you? And the other is, how do we get you better? We think both of those questions can be solved using data analysis. In fact, doctors solve them using data analysis every day. They just don't know that they are. The kinds of data that they generally use are image data, natural language data, and to a smaller extent, structured data. So I was previously president of Kaggle, which is a machine learning competition platform. Before that, I ran a couple of other companies. For the last 20 or so years, I've been working with machine learning, but in the last year or two, I've decided that everything other than deep learning is basically a waste of time, and I'm not spending any time on anything else anymore. I will say that in NLP, you know, deep learning is only just getting to the point that it's kind of state of the art, but it is more or less there now. In computer vision, that was the case from about 2011. And over the next couple of years, it'll be the case in every other subfield as well. So, but we spend all of our time pretty much at the cutting edge of academic research, trying to figure out how to do things like put a 150 megabyte three-dimensional MRI into a deep learning system and figure out whether somebody has cancer or not. Using stuff like this, we think we can, you know, potentially save millions of lives and make billions of dollars. So I think it's a really exciting area.
Thank you.
Hi, I'm Ben Pedrick. I work at Judicata, which is a startup around here that's making legal research software. Basically, that means it's a search engine for lawyers. The reason NLP is interesting to us is that the outcomes of court cases are written by judges in plain text. So if you want to know anything factual about what happens in a case, you need to go look into the text and figure out when the judge says this person sued over this issue and extract that information to provide it. The other thing that we are using NLP for a little bit and will be more in the future is we want to create a full map of legal concepts and how they relate to each other. And again, pulling this out of court documents and case text and say, okay, if this is, if it is unlawful to do this thing, then maybe there's like certain evidence that you need to provide, and being able to extract all that in an automated way to basically generate a whole view of the law. My background before this is in more systems and not so much in academic or NLP stuff. So I'm sure you all know a lot more about what's the state of the art right now and sort of what the big problems are going forward, but I might be able to provide a little more information on the problems that we face and sort of what the issues are that most face us right now. I think the biggest thing is that our requirements are very high in terms of precision and recall. The body of documents that we need to look at isn't that big. In California, there's 180,000 cases that we care about, which is really not that much. But for the information that we're taking out of it, we want to be on the order of like 99% plus precision and recall. And so that leads us to do a lot of tricks to work around limitations of the systems that are out there.
Thank you. So I think I'll pose one question to all of you. I think there is one question which covers all the use cases. So in order for NLP, AI, machine learning in general to work, to apply in practice, and I know Jeremy is on the faculty of Singularity University. So in order for Singularity to actually happen, right, we need the systems to really understand our intent, right? And I think the key problem with Siri, for instance, right, you say something and it gives you something else. So how do we really infer the intent behind the input, right? And I think, like, for instance, in case of endorsements, you know, a friend of mine endorsed me for sandwiches because I bought them good sandwiches, and what they really meant, they wanted to thank me for buying them a sandwich, right? I mean, probably this is very hard to infer, but you know, sometimes people endorse me for Ruby or Python, and what they really meant that they actually visit my profile. And basically, what I want to infer from this, they have no clue what I'm actually using, which is Scala, and none of these languages anymore. And right, so I can actually infer that they actually wanted to visit me and check me out, right? And you know, they provide useful information to LinkedIn.com that they did so. I mean, in case of social media, obviously, you can tweet anything and mean different things. You can say, oh, great, right? Like this Caltrain just went by, and you need to infer that this is sarcasm. I mean, in case of medicine, it's a little bit different, right? We need to infer what's really happening. So I don't know if there is human intent, there is nature's intent. So it's probably, I can kind of quite put it this way. But obviously, in case of legal cases, right, the lawyer is looking for specific precedents related to the case. So the intent is very clear. They don't want to lose the case, right? And they want to find all the things which apply to them and good for them, but not the other guy. And they're mortally afraid of losing this one piece which the other side will use against them, right? And so they cannot have anything but 100% recall, right? So we kind of will know this if we know we use the use case of individual application, and you know, as humans we can very quickly understand. So, but what if you can talk a little bit to your systems? What do you actually do in practice, and how good are you at inferring human intent, which may be different from what kind of the superficial examination of the input will tell you? Feel free to go in order.
I'll jump in because you jumped in on the endorsements example. So what I would say, for the specific example you gave, I actually would want to talk about another example because I think it captures the intent problem a little bit more. For endorsements, that's a very structured system, meaning in a way it's guardrails for people to tag each other, right? And the idea was to build kind of like a PageRank-like graph of topics in the same way that Google looks at anchor links on web pages and how they link to each other and what the anchor text is. We wanted to have a similar structured corpus of linked entities across user profiles on LinkedIn. And it had a semi-constrained vocabulary. So a lot of those endorsements that you're mentioning, some of them may have been organically entered by people saying, okay, I think he really knows Ruby. But it sounds like you're talking about examples where a suggestion was shown to them, hey, do you want to endorse him for Ruby? And they said yes, right? So in that case, the system is inserting itself. So I think that example is actually less about user intent. So their intent may have been, oh, yes, I like Alexy, and I want to show that I like him. And so I'll say yes. And they may not really know whether you know it or not. So I think that approach gets into this. The issue there is more about UI. So I think it's more about, you know, I think often what I see in data science and text and NLP in the applied world is a reluctance on scientists or researcher, on the side of scientists or researchers to be more proactive in the construction of the UI in the application and to mold that in a way where they get good results or they get good data. And there's often a trade-off between whatever primary metrics that are being measured in the system and collecting good data. So that's what I would say that is more about. With the challenges of intent, I think another great example would be autocomplete and something like iOS. And so as an example, so I think I turned off the actual maybe learning side or the personalization feature of iOS in my case. So I get worse results probably than normal. But if you're just using that default normal system, you'll get some pretty strange results, which if it knew the context of the user, you'd get better results, right? How many people have weird autocomplete results in their iOS, right? Okay, well, maybe it's just me. So
everybody else uses SwiftKey now.
Everyone else uses SwiftKey, so I'm behind the sun. But that's strange, right? You shouldn't have to install a special application to do that. And I think, to me,
Apple doesn't have very good ML people, I think.
Yeah, and I don't know if it's about having good people or not, but I think it does get to this idea of a mentality of using more signals and more data will get you closer to that intent, I think. If it's just something that's running online on the client side on the phone, that's obviously got it very, whatever they shipped as a pre-trained packet is all maybe that it could leverage.
I think on that one, you can just do it with better algorithms.
Sure.
Which I think SwiftKey has shown, and I think you can go further still, right? I mean,
Right.
the problem with NLP traditionally is it's been based on like n-grams and bag of words and stuff like that, and you use the word context, which is exactly the right way to think of it. Context in language is n words long, and who knows what n is, so we need to use sequence-based algorithms. So recurrent neural networks are, the thing that has finally allowed us to have language models that are actually accurate. So as soon as people start using RNN for autocomplete, you'll not have to switch it off anymore. They work incredibly reliably.
But you have a good benchmark, and Google arguably does it much better, right? So we know that this is more obtainable, right?
Yeah, I mean, they only use RNN for parts of their voice recognition, but I don't think they're still using it. I don't think anybody's using it yet for the language model. As I say, in NLP, deep learning is just in academia or at the point where it's starting to become the state of the art, so it's still not really in anybody's products yet at that level. But I mean, to me, your question about intent is kind of, I would express it differently, which is, I don't think we really need to care about intent or any other underlying causal driver. To me, the question is simply, can we do an action which is the best action at that point in time? That's all you ever need from a model, right? So you asked about medicine. In medicine, do I recommend the treatment that's got the highest probability of making you better at the lowest cost in the appropriate amount of time? And the same is true of if LinkedIn was saying, hey, here's the skill somebody has, then it's actually okay if we recruited that person, would we end up liking them for that skill? Or in autocomplete, if we suggest this word, do they end up clicking on this word? And this can be done through partly by being careful about the experimental design that you use for the data collection, and partly about using the right kind of algorithms. So rather than just using purely predictive modeling based algorithms, making sure that you pick an objective function where the metric you're optimizing is the kind of the uptick in the actual thing the action that you're trying to drive, rather than just the prediction that you're trying to make. And then questions like intent kind of become, they just fall out in the wash naturally, I think.
I think it's a good point. You brought up the recurrent neural networks. Obviously, in my line of work, using bag of words is completely infeasible. So you had to, but actually, obviously, those run into the problem of a short-term memory that they have, and then there's the more advanced solutions of the LTSMs.
Right.
But I think even with those, we've seen that even if you have the perfect understanding of language with more complex, longer-term memory neural networks for deep learning, I think, and my problem space is a little different, because somebody could say something that, even to a human being, if you look at the text, you're like, yes, this is an event. But when Harrison Ford, his plane crashed, everybody in the world posted that same post as if they were there, and clearly you can't predict that there's a plane crash everywhere on the planet. And that's where I think, at least in my field, the context, the intent, comes surrounded by what's going on around it, where if we are not only looking at the language, but we're also looking at the images, and we're looking at a view from space to know exactly what's in that location, and we're looking at a historical of understanding what that place is, what time of the day it is. Usually on Monday nights, this is what it's like, and then this is what the person is saying. I mean, it's just like if you're reading a book, they say, oh, he's painting a picture before setting the scene. Even in a book, we still visualize it. You still think of it visually, because without painting that picture, you can't really understand the text. So
well, this is why this is another reason why deep learning is so important,
exactly,
right? Because
yeah.
deep learning, and we have the same thing in medicine. We have the answers that the patient gave to the doctor's questions. We have the doctor's notes. We have the MRI scans, blah, blah, blah. And so the nice thing about deep learning is it converts everything into, this distributed representation space. So we can now create multimodal neural networks in which we can combine the images and the text and the structured data into a single mathematical, space where we can run queries or whatever. So I mean, we're starting to see a whole new kind of model of computation now appearing, where people are solving quite complex problems, you know, using these kind of distributed representations. It's a whole different way of thinking about things. So in the end, these RNNs, you know, to me, they don't. An RNN is not a tool that makes a prediction. An RNN is a tool that converts a sentence into a vector, into a distributed representation, which I can then add to the distributed representation of the images and the structured data and so forth, which is, yeah, it's a super cool thing we can now just starting to be able to do.
Yeah. The thing I would step back, if I, you know, reinterpreting your question again, another example would be, a common one is query intent for searches, right? So an example we would see at LinkedIn is, or I experience this myself, if I'm typing in, I don't know, Scala, right? It's pretty clear I'm looking for somebody who knows Scala, right? I'm probably not looking for somebody named Scala. It's possible somebody's named Scala. But I think that unless you are putting the right inputs or the right examples into your system and you set up the problem correctly, it's not like the system is magically going to infer that at the level of technology we have, right? So to get to what you're calling query intent, I think at this stage, currently, right now in production systems, you actually do need a bit more data scientist or human effort to craft feedback loops properly and gather the right training data to set those systems up.
Let me actually pick up on this feedback loops. I think that we've seen a few talks, and a theme is emerging that human in the loop, right? It can be useful, or more broadly, active learning. I think there is a lot of work in language was previously done by analyzing News Corpora, and it was inherently passive, right? Basically, you're listening, you're analyzing post factum. With social media, apps like LinkedIn, you're in an interactive environment, right? So I wonder how much of this mentality is kind of inertia, where we assume that people are doing something and we are just there to be there and interpret it. How much of actual experimentation is happening? For instance, I think in marketing, it would be very efficient to just send a lot of probes, right, and do A/B testing on live audiences and segment and see what works, instead of sort of doing a campaign the traditional way and analyzing it. And again, I think I would try to kind of gauge a bit more with Jeremy with the intent question, because I think the medicine domain. I think the intent is pretty clear. The cancer wants to kill you, the disease wants to kill you. So the intent is you can take the best action because you assume that you know exactly what the intent of the disease is, right? But in kind of in human situations, we may have somebody, for instance, social media. The fact that they're using social media doesn't tell us much. They're browsing. They're looking for something similar for LinkedIn. Somebody may be a recruiter. Somebody may be decorating their profile. Somebody may be browsing their colleagues or checking things out, right? So I wonder, and so the best action, I think it's very clear what the best action is in the context in the medical context, right? But in terms of human context, I think it may depend on your application, because you may choose to engage the user through some kind of active probing, right? You can show them something which you would not show to other people, right? And you can ask them to do something. And I wonder how much of this you see as, like, for instance, social media, how much of this is happening, how much of this can be happening, and what kind of tools do we have to do this experimentation in addition to learning passively about what is it users are trying to do.
What I would say is I think probably most of the systems that we work on have some user or a customer at some level. And I think, if the targeted prediction problem doesn't seem like user intent applies, maybe, I'm pretty sure it'll apply in whatever interface is being presented to the user. Another example of this I think I see is systems often neglect behavioral data, right? So even if you're mining across all of your user data or tracking data or marketing data to see, try to segment or predict what the intent was of a particular query, you get much better results if you can personalize it based on your behavioral history. So an example I'll pick on, is anyone from Yelp here? No. I think somebody from OpenTable is here, so I won't pick on OpenTable, but I'll pick on Yelp in that I'm a big Yelp user, but I feel like, for example, when I search on Yelp, I have to put in the same search facets over every time. Open now, near me, like I have a certain search behavior that I use, but it feels like it doesn't remember it, right, the next time I use it. And so that's something, you can call that another type of intent, which is we tend to do things in a habitual way. And if you can learn those habits, it makes things easier.
It's interesting to mention Yelp because I agree that their actual experience with the app seems that it doesn't know much about your history. However, their batch mode seems much better because they send you all these emails which are targeted, like I live in this bay, and they try to tell me here's what's happening in this bay. They have all these cute subjects which are supposedly will make me click and open this email, right? And so I think maybe that part is just in a different group, right? But I think there is some part of this experience, but it's not in the moment.
Yelp are like the anti-machine learning company. There's so much more that they could be doing. Like that's why, you shouldn't have to manually remember everything every time in UX. I mean, just the most obvious, simple machine learning would be able to figure out pretty quickly that it looks for things that are open now or prefers things that
that are open.
Or whatever. Yeah. All this manual programming can be massively cut down by using just the most simple machine learning models. It's a company that chooses not to for whatever reason.
I think a lot of companies are like that, though. Well, probably most.
Probably, yeah. Because I think a lot of CEOs don't understand, appreciate, or trust machine learning, so direct the engineers to use heuristics all the time.
So the other thing that we found is that for some of this, for generating intent, it's not a static process. It can be an interactive process. And so in terms of generating query, generating Yelp, something like that, like even just being able to suggest stuff out of your history and not set it would not be that hard, or to present, hey, I want to look in like an auto-suggest sense, I want to look for this thing in things that are open now or in things that are cater to, I don't know, my dietary concerns or whatever.
What you said about the CEOs, I do see that a lot, and I think it's a problem on both sides a little bit. I think a lot of times it's the miscommunication where you might have a team of data scientists that is not very business oriented, and so if their goals are not completely digested into a data science problem, then there's this miscommunication where you can have a data science team building great models, but to the business point of view, they're useless. And so you need someone to bridge that gap of, okay, stop thinking about data science for just a second. What is the business goal? Now transform it into digestible bits, and that it's unfortunate.
You need the data scientists involved in talking to customers and designing product and doing engineering. Places where the data science team sits out there in the Sunlight Tower. They just create kind of academically interesting but ultimately useless kind of things. Yeah.
Jeremy, what do you think? There are some, in some sense, like for things like social networks like Twitter, Facebook, LinkedIn, maybe it's easier because the people building these systems are also using them maybe heavily. It seems like it would be harder in a company where maybe, Yelp is maybe again not a good example for my point, but if you're using an application that's being sold to a completely different type of user, it may be harder for scientists to connect to the user.
Like I don't know what like
tools for salespeople say. If you're a data scientist.
I mean, I absolutely think there's no reason. I mean, maybe medicine's a good example.
Medicine,
right?
I was going to say too.
Like not many of our team have a long background in radiology, but we still spend most of our time sitting next to radiologists, looking at MRIs, trying to diagnose disease. And so, in the end, the radiologists at our company get reasonably good at machine learning, and the machine learning people in the company get reasonably good at radiology. And I think that's the trick to avoid the problem that Pedro was talking about, where there's this kind of mismatch in the end when the two people sit next to each other. It's kind of, rather than pair programming, we're kind of like doing like pair medical diagnostics. And it's like, okay, does this guy have lung cancer or not? And you have a radiologist and a deep learning practitioner sitting next to each other interactively trying to figure that out together.
Is that something in the legal domain?
Yeah, we have a very similar process where we have a handful of people who are lawyers and a handful of people who are engineers. And if we want to extract some kind of data out of a case, we'll sit down and look at it all together, and we'll both get a really good understanding of first, like what the information is and how it's presented and how we can get it, and then also what the limitations are in terms of the automated systems that we can get it out and where the hiccups are going to be.
And like Judicata and Enlitic are interesting examples, right? Because like lawyers and doctors are the things that probably all of us were told we were meant to be when we were growing up. I don't know, I know I was. And like here we are kind of like in the process of kind of automating and disrupting these industries with machine learning. I don't know, it's kind of interesting.
Robo-doctor and robo-lawyer.
I want to pick up actually on this interesting thing. So we talked about the dichotomy of data scientist versus business, right? And so I think this is a consensus that data scientists should be closer to the business goal, and this can be achieved in different ways. For instance, so at Nitro, actually, I'd like to propose this, and we hope we can do that. That I want to be a salesperson for the day, right? We have a sales team. And I'm personally, like, I want to make a sale, right? I want to talk to the customers, I want to understand what they're doing, and I want to convince them to buy a Nitro subscription. At the same time, I want to understand what is it we need to add to it as a cloud product, because we can just push things into the cloud platform, right? So I think that's clearly beneficial. The one thing which I don't know if we have a consensus on is how much data scientists should be engineers, right? So we have, I think there are two models. In one model, we have kind of a prima donna model where the data scientists can use whatever tools they want. They can use R and they can use MATLAB, and somebody else have to take the model and redo it in a production language, such as Java or Scala. And the other model is that everybody should be able to implement their own ideas, right? It's not reasonable for somebody to implement somebody else's ideas if they have their own. So, and it is possible to hire people who can do both things, right? Essentially to develop algorithms in a language or in a setup which is either immediately can be put into production or just need some expert performance improvements if that's the case, right? But, and that kind of increase the iteration cycle. But I wonder, from your experience, how feasible do you think that goal is, that at this point, data scientists should be engineers, or are they inherently different species?
This is something I've talked to a lot of people about and thought a lot about. So I don't have like a very definitive answer at this point. I used to think I had a definitive answer, but I've kind of softened over time.
What did you used to think?
I used to think everybody should try. No, let me take it back. I do think everyone should aspire to being at that intersection, right? Having solid engineering skills and some research skills and understand the business, right? I think the reality is that it's anytime you're doing those kinds of intersection operations, you're going to reduce the set of people that you can possibly hire, right? That's a smaller population. So the pragmatic reality is that
well, not necessarily, because the other thing you can do is you can hire people that have this strength, but then you try to teach them the other
sure.
things. So
No, that I think is something. I mean, I spend a lot of time both, hiring and thinking about this at LinkedIn, as well as working on it in a meta way at LinkedIn when we looked at the skills gap and the economic graph. And a big part of our mission was creating economic opportunity. And I think a lot of the analysis that you see out there in the media around the skills gap kind of misses the point when they say there's a shortage of X or Y. I think part of the problem is actually in the last 10 to 15 years, the recruiting mindset has leaned on tools that had very simplified ways of screening, which are like very just keyword matching based, right? So we have a database of resumes, we have a job description, and they do some pre-filtering, right? And if you don't overlap on the keywords, maybe they pre-screen you out. But that omits what you just said, which is you can hire and train people, and you can invest in training.
Yeah, let's say hire for what somebody can do, not for what they have done.
Yeah, so I think the mentality that I take now to get to short circuit my answer here is look for aptitude and hire for aptitude, and then level those people up. But in terms of what tools do you use, do you just once people are in the door, do you try to level them up in engineering, or do you just let them use whatever and throw it over the wall? I would lean towards trying to train people up. But I've seen companies doing both approaches, and you have to pick what works for your own environment.
I think what we saw at Kaggle was that we generally work with bigger companies, Fortune 500. We generally saw that they systematically erred on the side of treating everything as an engineering project, and like so they weren't allowed to use R or whatever the hell they wanted to use.
When you say they, what, you mean clients?
They being, so Kaggle's clients, so the data scientists wouldn't be allowed to use like whatever tools, they were told by IT that these are the tools they're allowed to use. And it wasn't just programming languages, but at least implicitly, it's like, if you use anything more than logistic regression, then management's going to tell you you're wasting your time being a prima donna or whatever. But then you see what happened when they actually brought something along to Kaggle, and they'd bring like Allstate, they bring like a critical question, like how do we figure out who's going to crash their car and cost us a shitload of money? It's like the most important thing an insurance company can do. And the answer basically is, well, use a gradient boosting machine instead of logistic regression, and you get an improvement of 270% in accuracy. And Allstate absolutely had the people that could have told them that there already, but they just never gave them that freedom. So I would say, my view definitely is go the prima donna approach, like find out what can be done, but then have them work in a project to implement something that has the kind of latency characteristics and fits into the infrastructure and so forth, knowing that, okay, 270% improvement is possible. We can get 240% improvement if we spend 3 months on it and have this latency and blah, blah, blah. I definitely think that's letting data scientists use very interactive, rapid prototyping tools is very valuable for stuff where answering that question well is critical to your bottom line.
To his point, then, would you say those data scientists should then learn, if the standard is to do it in Java and Scala, should they be learning that as well?
Yes, absolutely, but they shouldn't be using those tools to find the answer. They should know enough of those tools that once they know what can be done, that they can then work, pair program with, low latency, high scalability Scala engineers to kind of sit next to them and work together. So then when the Scala low latency, high scalability guy goes, oh, we have to make a choice here, like we could memoize this piece there, or we could recalculate it, and the machine learning person would go, oh, you could actually do neither with just a 1% decrease in error. We could avoid calculating this altogether because, frankly, this is kind of a bit of an unnecessary tweak. So that's why I would kind of say, yeah, have people that have specializations, but also try to have everybody know a little bit about what each other are doing and work really closely together. Kind of like the lawyers and the engineers working next to each other.
Yeah, I agree. It's bridging that same gap, but also it's much easier to have an ideal solution and then decide if you have to cut things and minimize the decrease in performance and accuracy. Then the other way around. You can't do it the other way around. Come up with a suboptimal solution and engineer it enough so that that's never going to go that way, right? So you have to start with what's the best and then start making the choices of the engineers.
I want to ask Ben about his specific case, right? So I think, so Judicata has this very interesting domain where, for instance, you need to do legal search, but you cannot really use Google or something like that because you have very specific constraints, right? You have to have recall. So on the one hand, we have a lot of different kind of machine learning problems which we can apply standard algorithms to, but in Judicata's case, and I think in many other companies which have corner cases, right, kind of represented here by Judicata, you have really specific constraints which make it not feasible to just take off-the-shelf solutions. So you have to simultaneously kind of engineer all algorithms, engineer on data pipelines, and then you have your own human lawyer reviewers. So I wonder if you can kind of illustrate on your use case how all these things are coming together and how much, you know, of off-the-shelf solutions you can take, what kind of algorithmic differences, improvements you need to do to make it work in your business case.
So one thing I'll mention, so for us, most of our data already exists because it's court cases that have already happened. So we can ask humans to go look at it and handle the cases that the algorithms don't get. So it's kind of the scale of, at the beginning, or with no automation, you could ask people to do everything, but that's really expensive, so you automate as much as you can, and then leave the rest to people, and it's more about finding the one that's the best cost for us. And so for us, finding there's like a limit to how far we want to invest into an automated solution, and we kind of want it to be tunable on the scale, and we have a small domain. So we can take off-the-shelf stuff, and that gets us like pretty far, and then we can write some of our own stuff on top of it that gets us a little bit farther. And then we hit a point where we realize that getting that last little bit is just way too costly, and so then we can stop. And so as a result, we're, I think, more due to the how limited our domain is, we end up doing a much more rule-based approach, which I'm sure makes all the machine learning folks cringe a little bit. But we're able to push that pretty far in a very short amount of time, which is really effective for us. So we kind of have the opposite problem with you guys, where we are more engineers who are like dabbling in data science than data scientists who are dabbling in engineering. But again, we can get it to where we need it to be.
So that's a good balance, right?
Yeah.
So I think this balance can also change by application. I think this is a good time to maybe have the audience ask us some questions. So if you want to ask a question, please come here and use this handheld I'll just give to you, so we'll have the recording. And you can address it to the whole panel, or you can address it to individual folks if you have questions. Oh, yeah, please. And if you want, we can line up here, and so we can be efficient.
Hi there. I found the need to improve on our solutions to make a human believe that we're doing a good job, to put a lot of domain knowledge into the system so we get the right terminology, so the little nuances are discovered. How important do you see that, and when do you think it's good enough to stop with the terminology work? Also, I suppose that there would be medicine ones and legal ones. You can't quite borrow. You have to sort of tailor yourself.
Can you say what application or what?
So ours is in consumer products, so there's just a lot of different ways to talk about a consumer product and what they are. So for us, we build a lexical ontology to help navigate the space of consumer products. There isn't one out there. Wikipedia is not able to help us there. And when we use distributional models to get the multidimensional vector space, so you can tell that it's making some very, very simple mistakes because it's not getting the nuances of what people are talking about. And then our humans that are looking at what we do can tell us that we're doing it wrong, because there's some obvious things that you're missing out, that this is not a color, this is not a fabric type, it just happens to be sort of similar.
Is this a B2B product?
Ours is an online advertising, so we help insert links into blogs or user-generated content and put it to affiliate marketing. So we found to be useful, but I haven't heard whether other domains have benefited from that, and it's unclear to me when you stop and when you start.
Yeah, I mean, the example I gave at the beginning of skills and endorsements, that was kind of the entire premise of that project was, I give an example, I don't remember the exact numbers, but we mapped those entities to Wikipedia as part of the pipeline, but it was more as a way to, we use that as a signal in some of the disambiguation, but we didn't strictly adhere to Wikipedia. And I think only a fraction of the skills or areas of expertise had a corresponding Wikipedia page or entry. So the vast majority of those skills are actually new entities that were defined on LinkedIn. And the other thing with something like Wikipedia or Freebase is probably richer, but they grow out of these, often grow out of communities where the rules are different, right? So what qualifies something to be an official, say, Wikipedia page, it has a bunch of strange community rules around it, around notability and things like that. So you always have to consider the source of those data sets or the labeled data that you're getting. So I think that's one of the most powerful things you can do in a domain-specific application is invest some time and energy into, and Google does this as well, and they just rolled out a knowledge graph. They have medical, you type in symptoms, you know, I was sick last week, so I typed in, you know, whatever my symptoms were, and a little knowledge graph thing pops up on the right with Google's inference of what disease you have, right? But they hired, I think, armies of contractors combined with, you know, machine learning to build out those domain by domain. So I think I don't know where we head, you know, 10 years from now, but it feels like right now that is the plan of attack that a lot of people are using in industry, whether it's Facebook or Google or LinkedIn.
Entity recognition or entity classification or whatever is saying a concept has a taxonomy or it has a category or whatever. And I just don't think that's accurate. It's not nuanced enough. And a concept or an entity actually has a nuanced, multidimensional kind of
sure. But if you do
seeing things, and as a distributed representation, you know, you get to express it in 600 dimensions. Sure. You know, and those 600 dimensions can interact with other representations in complex nonlinear ways. So, for example, I mean, I don't know if this sort of works on LinkedIn, because on LinkedIn you didn't have a lot of pros, but like on BigLink, I totally think it would, because you guys are looking at, you know, pros. And so you could really understand a word quite deeply in that rich multidimensional context and then find the appropriate subspace, you know, based on that particular document.
I'm not disagreeing. I think that, you know, when it comes to features, that totally makes sense. But when people want a single URL to click on, and so WebMD, it may be, okay, hand, foot, and mouth disease or something, right? So people do want to label. So I think it's not, so I don't disagree. Like, so linear, like, yes, using deep learning may be the right approach behind the scenes. I'm just advocating that getting rich labeled data or generating your own rich data from your audience, from your customers if you can, or hiring. So Google, the way I view it is they hire contractors essentially to like start building out some of those domains. But they can still use deep learning along with that.
So I guess what I'm saying is I feel like more of that should be done through reading.
Automated,
you know,
yeah.
Through reading, using deep learning, word-to-vec type stuff, and that kind of gives you those contexts and nuances, and then where you need to have human labeling, like you do at Judicata and like we do at Enlitic, that's where I would bring in active learning. You know, I would use active learning to then have the expensive human labelers label the highest value points.
I think that brings up the point of trade-off and loss of business decision that could be accomplished within a week or two or weeks of work versus a machine learning approach that would take a few more months to get there. And I think the fear is a lot of companies make the decision of, okay, let's wait 4 months to get it right without having to use an easier path. And that's one way. Obviously, in business, you want to win and you want to do it quicker. The problem is when they take that other path of perhaps taking a momentary, easier solution, it comes at a loss of doing it in a way that it hampers the vector representations because they embed the hackiness of this data into here, and then this could never grow anymore. So it's just finding a balance of making sure that this is not harmed, and you can still have that in a couple months, but in the meantime, attack the easier problem.
Yeah, and I don't know that the consultant or contractor approach of humans is any faster or easier. It's actually probably way more expensive in the long run.
I think for your average CEO at first it seems more appealing, like, you know, a kind of heuristic rules-based manual labeling approach. There's a clear path and the steps and whatever. Whereas to me, I think the machine learning approach often is faster and cheaper, but it's just somebody who's
it seems high risk.
Yeah. It seems a little mysterious or magical or something.
So if the company hasn't done what you're describing before,
probably
that is almost
terrifying.
it's not infinite risk, but the perception would be it's very high risk.
Right.
I'm curious, you mentioned vector representation, so I'm guessing you're using something like Word2Vec or some kind of vector.
Sure, yeah, we've used Word2Vec to
Yeah.
explore our data.
Yeah. I'm just curious, were you looking at direction information too, or just proximity, like an overall distance measure?
Basic skipgrams of words on our text, and then do some exploration of the space, finding clusters in there to make sure that when you say eggplant, it's the color versus the vegetable, or when you say cancer, it's the zodiac sign versus the disease. So there's a lot of places where it gets really convoluted.
So have you used, because you can actually break up the same word into multiple meanings and then have them represented in different places in Word2Vec.
Right.
Right. Exactly. So I don't know if you tried that. But
Oh yeah,
that's
sure.
something to look
There's really interesting stuff there. It's amazing, but it's losing the edge for a human. A human can spot us and tell us, "Wow, you're not bad, but not good enough." We need to layer in a lot of human knowledge to get it above the bar to say, okay, now now I can trust you. Is what we're finding. And so it doesn't sound like you, for example, Jeremy, that you're building a terminology,
We have
dictionary.
a terminology dictionary, in medicine, where there are the distributed representations of words that you see in medical reports. And I mean, in some ways, we have it a little bit easier because the lexicon and structure of, say, a radiology report is a little more well-defined than some. So for me, I feel like what we're seeing it in with it, because we've kind of picked this easier, simplified domain, maybe represents what might be possible in a more general sense in 3 to 5 years' time. I think it's kind of, if you see somebody say fracture, for example, in a radiology report, it's very unlikely they're talking about fracking for oil. They're probably talking about a bone, for instance. So, I think we're working in a somewhat easier domain. It seems to work pretty well.
For us, we do spend a lot of time just manually looking at words, manually curating lists, generating it quickly, and just going through and checking it off. And again, I think it's because our domain is small and we have a really good sense of the bounds of it, which I guess doesn't really help your question, because your question is kind of what is the bounds. But for us, since we know what we look at, because it's search-based, we can just kind of look at user queries and say, okay, these are what they're looking for. These are the things that we need to understand that maybe we don't right now. That helps us a lot inform how far we need to take it, and lets us round out our data pretty quickly.
Do we have any other questions from the audience? If not, maybe, okay, we have one. Awesome, thank you.
So what are your guys' thoughts on using the representations as a way to augment something that's labeled? So in this case, like using WordNet as part of the neural word embeddings, for example, so you can get automatic disambiguation with the augmented senses, and then also like in the domain of factoid QA, like something like Watson, where it disambiguates the answer for you, gives you one answer, and it's focused on giving you one answer, and you use the mixed representations as part of the overall curated list or like possible set of answers. So basically using that as a signal for answer candidates and the like.
Yeah, I think the general idea is a good one, Adam. To me, the trick it depends kind of on how much data you have, right? I mean, if you have, like when Google actually did Word2Vec, they were reading books, and they have Google Books, and they kind of had enough data, and I don't think things like WordNet were going to add a hell of a lot to that. For us, we have X 100,000 or X million medical reports, and it's, or images. And anytime you have any kind of data shortage like that, the trick in deep learning, as you well know, is data augmentation. And so to me, things like using WorkNet and stuff like that are ways that we can do in NLP, the kind of data augmentation that images we do with like reflections and rotations and blah, blah, blah. It's kind of like, hey, let's generate some semantically equivalent, grammatically correct sentences using external sources. Like, I think that would be how maybe I would use WordNet, but I'm not sure that anybody's, you might know, has actually studied whether that compared to using WordNet for post-processing, for example, is a better approach. But for me, you know, like the right way to do deep learning is augmentation. You know, that's my bias.
Yeah, I'd add in, you know, so I'm no longer at LinkedIn now, so the projects, the things that I'm working on now, you're starting, you know, it's one thing when you're at Google or you're at LinkedIn and you're starting from a large data set of, you know, hundreds of millions or billions of documents or users. But without that, I think when you're bootstrapping a system, I think go for it. You know, it pays to be a little scrappy. The thing that, you know, it's a nice problem to have if, you know, this, whatever system you're building gets traction and is useful, and then you have to replace that stuff. But you may hit a point, you probably will likely hit a point if it's successful, where you have to reevaluate that. And I think in the example of skills, we bootstrapped, there was an old section on LinkedIn called specialties, which was basically a free text field that people could put comma-separated keywords, or they could put whatever they wanted. So some of them were sentences, some of them were comma-separated fields, bullets, things like that. And we started by mining unsupervised from that section and using Wikipedia and using other data sets initially to build you know, the set of topics. And then over time, when people started adding skills to their profile, we switched completely to that data source. And got off of all the other things. So I think, like in general, I think that would be, that would make sense. But you're probably on your own, like you said.
Any other questions from the audience? If not, maybe we can wrap up with kind of a question to each of you, and you can answer them in order. What should we, as a community of data scientists and engineers working in NLP, do to make NLP more efficient in practice? So from your use cases, from your applications, where did you see some areas where you wish you could invest more effort into learning about algorithms, maybe throw in more brain power into something? What is the kind of low-hanging fruit? What should we go after in the current state, right? Where can you make the best improvement? What do you think will get us closer to singularity?
Singularity? You're assuming we want to do that?
Or at least, you know, make Siri not really like get really confused, right? Like get to a better Siri. Let's just make a kind of a better wish, right?
So I would say recurrent neural networks. You know, like if you're in academia, pick any state-of-the-art problem and redo it with recurrent neural networks. Every time I've seen somebody do that in the last 12 months, they've had a paper in a high citation journal and kicked ass.
Or 5 at the same time.
Yeah, well, exactly. You know, there's been plenty of recent journal articles, which is basically, hey, I picked 12 challenges, state-of-the-art problems, and tackled them all with the same obvious naive approach, and I just surpassed every single one of them. And it's
or
like
even better, combine it with reinforcement learning. And
yeah, normally that would be 12 papers, but hey, I don't have time to write 12, so here's one. Or do the same, if you're an entrepreneur, do the same thing in startups, like pick, you know, problem to solve X and do that plus deep learning. It really reminds me of the early days of the internet, you know, in the early 90s. It's like, what should I do? Should I do like e-commerce, books, stuff in government, blah, blah, blah. It's like X plus internet. It's like, well, every single one of them. You know, internet's going to impact everything, so just pick anything you like plus internet. It's the same, yeah, almost. So I would go there. Like if you made another Swift key clone but with an RNN, I bet it would be so much better than everybody else's, you know, keyboard program. It would take over, for instance, to pick something at random that we mentioned today.
Yeah, I think for us, the problems we're facing are not so exotic that all these approaches that everybody is working on would Western health, the biggest issue that we face is that because it's so domain specific, the data sets that are out there don't work very well for us, making it most expensive. So, similar to what's been previously mentioned, getting data that is you can feed in that is useful to you is a big issue for working in a domain specific field.
Okay. Well, I mean, I now feel so re-energized that about deep learning, I want just to go back and like really dig into this. Thanks to Jeremy. But I think this is true because it applies to things like documents, and I mean, obviously the recent work from Jan Lagun's lab is very encouraging. Although it does seem a bit magical, right? Because like you just feed this sequence of characters and don't care how they make words and even in which language. That still looks like magic, but maybe it will get us there. Thank you, everybody. This was a great panel. Really appreciate your contribution. The plan for the rest of the evening is as follows. We have a taco bar, we have ice cream and wine reception, and we have some board games. So the idea that if you want to hang around and chat to people, we have board games laid out on the tables. You know, you feel free to play them or not, but we'll have the tables. And we did this at Scala, by the way. It was a really great experience because we could just hang around and chat, you know, around this games or actually play them. It's up to you. We have a lot of them, and it will all be happening upstairs.